Hello बच्चों, let's read this question. A particle that is moving in xy plane has a position vector which is given by r vector equals to 3t cube minus 60 I cap plus 7 minus 8 t raised to the power 4 j cap, where r is measured in meters, t is measured in seconds. For time t equals to 3 seconds, in unit vector notation, find position vector, velocity vector, and C acceleration vector. Moreover, find the angle between positive direction of x-axis and a line that is tangent to the path of the particle at time t equals to 3 seconds. So students, इस क्वेश्चन में हमें पोजीशन ऑफ पार्टिकल एज अ फंक्शन ऑफ टाइम दिया गया है. दिस इज 3t³ minus 60 I cap plus 7 minus 8 into t raised to the power 4 j cap, where r is in meters. So students, at time t equals to 3 seconds पर हमें बताना है कि इस पार्टिकल का पोजीशन वेक्टर क्या होगा, वेलोसिटी वेक्टर क्या होगा और एक्सेलरेशन वेक्टर क्या होगा. और पार्ट डी में हमें बोला गया है कि इस पार्टिकल के पाथ से टाइम इक्वल्स टू 3 सेकंड पर जो टेंजेंट लाइन होगी, लेट्स सपोज दिस वाज द पाथ, तो इस पॉइंट पर इस पार्टिकल के पाथ पर जो टेंजेंट लाइन होगी वो एक्स एक्सिस से कितना एंगल बना रही होगी. सो प्लीज नोट द की कॉन्सेप्ट ऑफ दिस क्वेश्चन, which says the velocity vector v is defined as differentiation of position vector r with respect to time, and acceleration vector a is defined as differentiation of velocity vector with respect to time t. So students, in first part or in part A, we were required to find the position vector at time t equals to 3 seconds. So students, हम सीधा ही इस इक्वेशन में t की वैल्यू 3 पुट कर सकते हैं. दिस वाज 3t³ minus 60 I cap plus 7 minus 8 into t raised to the power 4 j cap. We are concerned with finding position vector at time t equals to 3 seconds. So students, substituting 3 wherever we find t, plus 7 minus 8 into 3 raised to the power 4 j cap. Students, this will be 81 minus 18 I cap plus 7 minus 8 into 81 j cap. Upon evaluating, you will get this is 63 I cap minus 641 j cap, and this is the value of position vector at time t equals to 3 seconds. In part B, we were required to find velocity vector at time t equals to 3 seconds. For that, we need to find this velocity vector, which is defined as the differentiation of position vector r with respect to time. So differentiating this equation, 3t³ minus 60 d by dt of 3t³ minus 60 I cap plus differentiating the j term 7 minus 8 into t raised to the power 4 j cap. Upon differentiating this I cap terms, this will be 9t square minus 6 I cap plus differentiation of this constant 7 will be 0, 0 minus 32 into t raised to the power 3 j cap. Finally, we arrive velocity vector function 9t square minus 6 I cap minus 32 t cube j cap. So students, velocity at time t equals to 3 we can find by simply putting the value of 3. 3 square will be 9 minus 6 I cap minus 32 into 3 cube. Directly we can write 27 j cap. On evaluating, you will get this as 75 I cap minus 864 j cap. This is the solution of part B of this question. This was the solution of part A of this question. Now in part C, we were required to find acceleration at time t equals to 3. Same procedure we will follow, but this time we will differentiate velocity with respect to time. Now velocity we calculated 9 t square minus 6, differentiating the I cap terms, 9 t square minus 6 I cap plus d by dt of minus 32 t cube j cap. This will be 18t, and differentiation of this minus 6 will be 0. This is I cap plus differentiation of minus 32 t raised to the power 3. This will be minus 96 t square j cap. Now substituting the value of t as 3, this will be 54 I cap plus minus 864 j cap, and this is the answer of part C of this question. In part D, we were required to find, suppose this was the curve of the particle, or this was the path of the particle. Now at time t equals to 3, particles position vector is suppose x comma y, and we are required to find, this is our x-axis and this is our y-axis. Now we are required to find what angle this slope makes with x-axis. So students, we are concerned with finding the slope m, and slope m in any curve is defined as y value upon x value. This is also equals to tan theta. Or simply students, you can understand we have traveled, let's say, x distance in x-axis and y distance along y-axis, and we are required to find this angle theta. So directly using trigonometry in this right angle triangle, we can find tan theta equals to y upon x. Now at time t equals to 3 seconds, what will be its y value? Its y value was minus 641, and its x value 63, and theta equals to tan inverse minus 641 upon 63. From here we will get theta as roughly equals to minus 84.28 degree. But students, do negative angle makes any sense? Yes, because we are measuring the angle in positive anti-clockwise direction. This was the angle, and we are measuring in clockwise direction instead of anti-clockwise direction. So angle will definitely come out to be a negative. I hope you understood the concept, students. Thank you.